Hello, and welcome to your OPS 245 Week 11 lecture video. This week we've got two sets of slides we're going to work through. The first, we're going to talk about configuring SSHD, well, configuring a service in general, but specifically you're going to configure SSHD in the lab. It's the SSH service daemon. And in the second slide of slides, we're going to look at IP tables, which is an old firewall in Linux. It's been around for a long time. It's still kind of in use, although it's starting to slowly be replaced with other things. But it's still a good thing to learn. So, without any delay, let's get into SSH. So we're going to be configuring the SSH server, because you've already used SSH on the client side, so you know most of that stuff. And SSH is a super useful thing as a Linux administrator because you use it for remote access into systems. So as a system administrator, you're going to be setting up networks. You're going to be configuring networks. You're going to be managing networks. You're going to be adding new services and maintaining a network. We talked about how to set up a virtual network in Lab 6. But once it's set up, you have to, I already kind of touched on this, right? You have to maintain it, not just the network, but everything that is a part of the network too, which includes troubleshooting, fixing issues, maintaining security, which is a constant thing. Now, part of securing a network is hardening your servers to prevent unauthorized access. So hardening a system can range from running an intrusion detection system or an intrusion prevention system or both, monitoring and flagging suspicious activity, which IDSs and IPSs help you do, right? And implementing security policies by using firewalls, both on the servers themselves and maybe firewall appliances. All kinds of useful things, right? Even setting timeouts to lock workstations and stuff. So we're going to look at SSH. And you're going to configure SSH for remote access. You should be familiar with SSH because you've already been using it for almost 2 semesters at this point, right? It stands for Secure Shell, and it's an encrypted network protocol for running unsecure services through a secure tunnel. So you can do things remotely. You can do all kinds of cool things remotely that you haven't done with SSH yet. But one of the most common things that you do for SSH is to remote access systems and routers and switches as well. So you can access the command line and make configuration changes or check the configuration or do whatever needs to be done without actually having to be physically connected to the computer. And you did this in ULI 101 last semester, right? You used SSH to connect to Matrix. So SSH is a client server oriented protocol, right? When you're accessing whatever device you're accessing from, that's the client. And whatever device you're accessing remotely, be it Matrix, that's the host or the server. Now in ULI 101, you were the client connecting to Matrix, right? But for Lab 7, you're going to actually set up SSH servers on your virtual machines. And the one we use in CentOS, and it's a very popular SSH server, is OpenSSH. Once it's installed, you can interact with the service daemon, SSHD. You can start it, you can stop it, you can restart it, you can check its status. We've dealt with managing services a little bit, right? It's usually installed by default. You can check it with either rpm-qa and grep for SSH, or yuminfo OpenSSH server will give you that information. Now, the server itself, its configuration file is in etc, right? An important directory, ssh, sshd underscore config. And it's a file. So we're just going to straight up use vi or nano to modify that file to make changes. And anytime you change a service, you need to restart the associated service. So sudo systemctl restart sshd, and then you might want to issue status to see if it's actually running, or if it failed, to get more information about why it failed. Now, one of the most common things that causes a service to fail starting is a typo in or a syntax error, typo, same thing, in the configuration file. So that's one of the things to look for. Now, our virtual machines, they're open to the internet, sort of, right? But they're also only open to the internet from within Seneca's network, and only when your server's on. So security is kind of a concern, but it's not as much of a concern as it would be if it was accessible just straight up on the internet, right? But that doesn't mean we shouldn't think about it. And we can secure SSH in a couple different ways. We can disallow root login. So that's just one thing off the bat. We can just in the configuration file issue permit root login, or the parameter in the config file permit root login. Set that to no. It will disallow root from remotely accessing your server, which you shouldn't be remote accessing servers with root anyway. You can also specify users that are allowed to access your server in the allow users parameters. That'll make it a little bit more secure. If you're the only one, or maybe you got a handful of admins that are going to be remote accessing this thing, you can list them. I mention the security stuff because it's worth thinking about as a network admin. I've mentioned in the past, right? Once upon a time, if you were a network admin, you didn't need to think about security. The security team did that. Well, now, with everything migrating to the cloud, that's not the case anymore, right? You need to think about security and how things impact everything as part of your configuration. And I want you to take that with you going out of this course into next semester when you take OPS 345, because you are going to be working with AWS. So you're going to be spinning up instances that are on the internet in the cloud, right? So you got to think about security a little bit. Now, another security measure we can layer on, passwords are kind of a horrible thing, right? Because you can there's programs that you can run that you can brute force these, right? But we could use keys. We could generate private and public keys, a key pair, and use that to log in. And then you can only SSH into the server or remote access it if you have that key pair, right? Or at least the one half of the key pair. It's a useful thing. It'll help you secure it a bit more and make your life a bit easier. The downside, if you lose that key and you don't know your password, you're locked out, right? And you're going to be using this next semester in OPS 345 as well. So public and private keys, you've got your server that's got the public key on it. Something's not quite right here. You generate them on your client usually. You initiate the session. The server will send a random message that can only be decrypted with the corresponding private key. Well, this graphic is confusing the shit out of me because I'm not understanding what they're trying to get through. I was going to go a different direction, which is why this may not make as much sense. The client will send an encrypted message. It gets decrypted, and if it matches the original one sent, then we know that you have the proper keys and you're authenticated on the network. This could have been depicted a bit better, I think. So to use a key pair, you need to generate them first. So you use SSH keygen to do that. And then you could just copy them using SCP. But why bother? SSH has a command built in, SSH copy ID, and then followed by the username at the server name or IP address that you want it copied to, and it'll do it. If you're storing your keys in a non-default location, you can use the -I option to provide the path to the key. Usually just store them in the default location or the default name, but not always. You might have keys for more than one server, so you might have different names for them. So you need your username and password to copy the key over, right? And it's important to remember which file is the public key. Your private key never leaves the server. That's what makes this secure. So we use these because they're faster, they're more convenient, they're more secure. You can authenticate that not only is that person allowed access, right, but they are likely who they say they are, unless they've done something really stupid like put their private key online and it got compromised or something, right? So there's useful things we can do here, right? Useful things. It will also detect if there's any kind of ARP poisoning, like DNS spoofing or man-in-the-middle attack. That's happening. Something funny's going on. When you try to connect, you'll get a message like this, and it'll tell you, hey, something's going on that's wrong. Could be that your key changed, but maybe somebody's trying to do something funny. And if it is, you changed the key or whatever and you forgot to copy it over, just correct the configuration and do it again. You're good to go. Because that happens sometimes. You can do some other cool stuff with SSH too, though, not just for remote access. You can actually run graphical applications using X11 forwarding over the network. This is how I was doing things last fall before my desktop completely died. The audio jacks in the front were going, so I was recording stuff on my wife's computer using virtual machines that were on my computer, and I was accessing them using SSH with X11 forwarding. It was pretty awesome. So when you do this, you create an SSH tunnel, and then you can launch graphical applications through that tunnel on your local computer as if they were actually there, but they're actually being executed on the remote machine. If that makes sense. So to do this, I just issue SSH with a couple options. -X, which enables X11 forwarding, -C, which enables compression that gives you a bit better performance, and then followed by your username at the server name, and you're logged in. And when you initially log in, you don't get a graphical anything, you just get a terminal, right, on the remote machine. But you can launch commands graphically, and they will pop up on your local machine. They're really being executed from the remote server. So things like gedit, right? It's pretty handy. Only works though if that has been allowed on the source system that you're getting into. So that's SSH. You're going to learn how to configure it in the lab. Hopefully that makes a little more sense, and you see more benefits to SSH aside from just accessing Matrix to do your ULI tutorials, which you did last semester. And that is it for lecture 1 of 2. So that brings us to lecture 2 of 2. We're going to learn all about firewalls, specifically IP tables. So a firewall isn't just something annoying that gets in your way when you're trying to access something over the network. That's what they tend to be when you're a student, right? You're trying to configure stuff, the firewall gets in the way because you don't know how to configure it. Firewalls are utilities that allow or block access to services over the network. And you can configure these to specifically allow or specifically block things. And there's a default policy that we're going to look at in a little bit. All network applications and all network data that's sent and received goes through that firewall. So it's an important thing. It's filtering packets. It's not looking at the packets, it's just looking at the information in the header, the source and destination, IP address, and or ports. Everything inside is still not tampered with, right? It's just filtering based on what's in the header. So one of the first things we did in Labs 1 and 2 is we removed Firewall D and installed IP tables. IP tables is a bit older, but it's pretty standard. A lot of companies still use IP tables. Firewall D was an attempt to replace IP tables, and that didn't go over so well. There's a newer firewall that's out now, NF tables. It's been out for a couple of years, more than a couple of years now, and the syntax is a lot like IP tables, and it's catching on. In fact, distributions like Red Hat Enterprise Linux have deprecated IP tables and moved to NF tables completely. And one of the things that they did right with NF tables is they made it backwards compatible with IP tables, at least in the sense that there's scripts and commands you can use that will take your IP tables configuration and translate it to NF tables configuration. They didn't do that with Firewall D, so it didn't catch on. So we stopped and we removed Firewall D. If you didn't do that, you're going to want to do that first, because if you're trying to do this stuff with Firewall D, Firewall D is going to cause issues. We're using IP tables. So how does it work? Well, in a firewall, there's a series of rules, and they're applied sequentially. The packet is matched against each of the rules in sequence until a match is found. And if a matching rule is found, that action's taken. Examples are accept, drop, or reject. Drop and reject are a little bit different, but they effectively have the same overall effect, right? The packet doesn't get through. If the packet doesn't match any of the rules, it goes through the default policy, whatever that default policy is. We're going to look at that in a few minutes. Now you can use chains that are built in by default with IP tables. There's different chains. There's several different chains, but we're going to deal with 3. To group rules together to apply to specific packets. The 3 chains we're going to be using are input, which applies to packets that are coming into the server. All of these are from the firewall and the server's perspective, right? Output, that applies to packets that are leaving the server. And forward, anything in that chain is applied to packets that are being routed through to another server, right? So it's being passed from one to another. If you're doing port forwarding or something like that. So here's an example. We've got our policy, right? We've got some rules in there. We've got our default policy. If the packet goes to the first one, it's checked against that, right? If it finds a match, it takes whatever action is associated with that rule. If there's no match, it goes to the second rule. Same thing, if there's a match, that action's taken. Otherwise, it goes to the third rule. If there's a match, that action's taken. Otherwise, it keeps going until it gets to the default policy, at which point that's applied, whatever it is. There's some best practices here, and we'll talk about them shortly. So to configure IP tables, we use the IP tables command, and it allows you to set up policies to control access to the packets based on ports, protocols, source and destination IP, all kinds of fun stuff. And just like we've done previously with other labs, you want to make sure that your current firewall is active before you make any changes. And even after you make changes, right? You tend to want to double check and make sure that your changes took effect, right? So some useful commands for that. iptables -uppercase L lists all the rules in your your chains, input, output, forward, and any other chains that are existing on the system. You might want -L-V, and that will verbosely list all the rules, so it gives you things like a total number of packets affected, so you'll see if your rules are matching traffic or not. And you can also just list the rules for a particular chain with iptables-L, and then you give it the chain name, right? So if you only want to see the rules for the input chain, for example, because that's where you're making changes, you can do that. It's just a handy thing. One of the first things you want to do before you're doing anything is flush the current rules. And you do that with iptables-F. That's going to clear all the rules for all the chains so you can load in your own custom rules, and they won't conflict with the defaults that are there, because there are defaults. iptables-F, and then the chain name will flush or clear the rules just for that particular chain, so it could be useful. You have to keep in mind, though, that every chain has a default policy, and you can modify that. When you flush the rules, that default policy is not changed back. So if you set the default policy to drop everything and then you flush the rules, no traffic's getting through in that direction, whether it's input, output, or forward. Depends on what chain you've applied that to, right? Finally, default policies. Well, I say finally, we're not quite finally there yet, right? Default policies are a useful thing. Remember, we talked about rules and how they're applied sequentially. The default policy is the thing that's applied if none of the rules match that particular packet, or that packet doesn't match any of the particular rules. You tend to want to set these. And a good practice, at least for the input chain, is to set these to drop. Think about it from a logical perspective for a second. If you have it set to accept, then you have to think about all the types of traffic that you don't want coming into your server and create rules to block them, right? Well, it's probably a smaller list of things that you actually want incoming, right? Say you've got a web server and you've got remote access, so you need SSH as well. So you need inbound web traffic and inbound SSH traffic. That's it, right? So if you set the default policy to drop, and then you only add rules to allow those two ports, life's pretty good, isn't it? It makes it a lot easier, and it makes it a lot more secure. This is a common practice, not just in Linux, but every operating system firewall and even hardware firewall appliances. So we can set the default policy with iptables-P, then the name of the chain you want to set the policy for, and then either drop or accept. Which one do you want to set it to? Probably drop, right? Now, if you set it to drop and then flush your rules, as I mentioned, nothing's getting through, right? So if you're going to clean up everything, you want to just allow everything, flush the rules, and set it to accept. But we don't want to do that. We're going to try to be good sysadmins. Now, when you're creating your rules, there's a few things you have to keep in mind. What type of traffic are you trying to filter and trying to match? And in what direction is it coming in reference to the server, right? Because that's going to affect what chain it's going into. So I'll give you an example. I've already mentioned inbound traffic, HTTP traffic, which is port 80. Well, it's incoming to the server, right? It's a web server. So that's going to go in the input chain, right? It's not going to go in the forward. It's not going to go in the output. It's going to go in the input chain. So think about things like that, right? Think about what type of traffic you're trying to match. There's a useful file here, etc services. You can just cat that and pipe the output to grep for the protocol that you're trying to filter, and it'll give you all the port numbers, which is great. You don't have to remember them. And if you can't remember that, you can Google. There's a list on Wikipedia. I'm sure you can find it. So when you create your rule, you got to think about which direction, the type of traffic you're trying to match, and what you want to do with it, right? Accept, drop, reject. There's more possibilities, but we're just going to deal with those three because firewalls can get pretty complicated. Now for matching packets, there's a whole bunch of options to match packets, and you can use any of these in combination, which makes your things a lot more complicated but also a lot more specific, right? So -S and the source IP address, that's the whoever sent the traffic, right? -D and the IP address again, that's the destination IP address, where is it going? You can specify the protocol specifically with the -P option, followed by the protocol, so this could be TCP, UDP, ICMP, or all. You can specify the source and destination port you want this applied to with -D port and -S port. And that's only available if you specify the protocol. You can also specify the incoming or outgoing interface, which you may want all of these, you may not want all of these, you may want some of them. Just know the options are there, right? Because it's handy. So you can combine these as needed to match traffic, right? So specifically, ICMP traffic sent from a known network. That could be a useful thing, right? It's the tricky part with IP tables is figuring out which options to combine to match the traffic you want, and then test it, right? Anytime you're doing anything with security, it's a constant cycle of implement new measures, test, revise, implement new measures, test, revise, right? You're always testing. It's a constant cycle. So now that we know how we're going to, well, what our options are available to us for matching traffic and what we're going to do with it, let's actually look at some examples of how to do it. So putting an IP tables rule together, and this gets complicated too. You need sudo for this, right? Or have switched using sudo -I, so your root until you hit exit, right? And then you're going to issue IP tables -I, and there's other options here that we're going to look at. The chain, so input, output, or forward. Then your traffic matching options, so your destination port, your source port, your destination source IP address, your protocol, all that fun stuff that we just looked at, right? And then -J for jump to the target. The target is the action that you want to take on this traffic, right? So that's going to be your accept, reject, or drop. And again, there's others. Now, inserting rules with I is useful. But remember, I mentioned earlier that IP tables rules apply in sequence. So, what happens if you want it to go lower in the chain? Well, there's an option. -I inserts it at the top of the chain. You could use -A instead, and that will append it to the end of the chain, which could be useful. And what happens if you want to move stuff around? Well, you need to know what order they're in, right? So IP tables -uppercase L -V --line will give you a list of the rules with their line numbers. And then if you made a mistake, you can just delete it by the line number. IP tables -D for delete, the chain you want it deleted from, and the number or sequence in the chain it is. So this would delete the third rule from the input chain. Could be useful. Once you've done all that, you're going to want to save them, right? Because they're only going to stay that way until you reboot. You didn't save them. So you could use the iptables save command, and that will save everything about your current rules, and you can redirect that to etc sysconfig iptables. That's the configuration file that iptables reads from when it starts. So just save it there. You're good to go. You might want a backup copy of that first though, right? Anytime you're going to change or overwrite a configuration file, you probably want to back up first. Now, like everything in this course, Do I expect you to be an expert with IP tables in a week? No. Do I expect you to master IP tables in a week? No. You learned some basics, and you learned kind of how to put them together. You're going to get some things right. You're going to make mistakes. You're going to get some things wrong, and you're going to learn from those mistakes. I want to leave you with, I think I may have mentioned this before, but a quote from a friend of mine who has been a Linux admin and been using Linux since we were in high school. Hasn't been a Linux admin that long, but he's been using Linux that long. When I first started teaching OPS 335, which was the first course I taught, the predecessor to OPS 345, I asked him, because I didn't feel my confidence in my IP tables abilities weren't super strong. I wasn't very confident. And so I asked him, I said, hey, how good are you at IP tables? Could you look over some stuff for me? And you know what his response was? I'm as good as Google lets me be. And 9 years later, I'm still telling that story. You too are gonna do that, right? You're gonna be as good as Google lets you be. You're gonna know some stuff. You're gonna understand the fundamentals, and you're gonna be able to use the tools that you know in conjunction with the tools at your disposal, i.e. Google and the internet, to find the information on how to do what it is that you're trying to do. Because most of the stuff that we're doing, really pretty much everything we do, is just a variation of something else that somebody else has already done. So if you can find a walkthrough on how to do something and tailor that to your needs for your particular configuration, that's a far more useful skill than memorizing syntax. So with that, take care, be safe, have a good week, and I will see you in this week's lab class. Bye for now.